All right, welcome everybody. Let's do this. So let's continue L'Hopital's rule for trigonometric functions. And whenever we have some ln like this, we call them transcendental functions. So how can we actually solve this? Let's see. The limit as x approaches -2 for this huge blob of a thing, right? So the first question you need to ask yourself, can we plug in -2? Question mark, right? Because if we plug in -2 into the denominator and it becomes 0 or infinity, we have a problem. So let's see what happens. So if you have, let's look at just the denominator. If I have 4 ln of -3 minus 2x plus x cubed, and we're going to plug in -2, this becomes 4 ln -3 minus 2 times -2 plus -2 cubed. So then this is 4 ln -3 plus 4, and this becomes -2 cubed is -8. So now you have 4 times ln of 1 minus 8. And now here you have 4 times, what is ln of 1? This is 0 and minus 8. So you just have 4 times 0, which is 0, and 0 minus 8 is -8. So notice that we get -8 for the denominator, and you're allowed to plug in -2. So if you felt like, oh, I have no idea why ln of 1 is equal to 0, I will show you in class tomorrow. But for now, just accept the fact that ln of 1 is 0. Okay, because if I were to explain it, it's going to take too much time. But I'll definitely show you tomorrow. So we have -8 on the bottom. So this is good. We don't even need to use any tricks. We just have to plug in -2. And let's look at the top. Here you have 3 cosine of x plus 2 plus x. So now let's plug in -2. So then you have 3 times cosine of -2 plus 2 plus a -2. And that's over -8. So now you have 3 times cosine of 0 minus 2 over -8. Okay. And let's see, 3 times, what is cosine of 0? Shout out to Frank for saying that the cosine of 0 is 1. So this is 3 times 1 minus 2 over -8. So that's 3 minus 2 over -8. That's just -1 over 8. And that's it. We're done. Okay? Some of you are probably like, why did Frank get the shout out? But it's all good, Frank. I got you. All right. So for this one, we were allowed to just like plug in -2. So we didn't have to really use L'Hopital's rule at all. Let's look at the next question below. Here it's saying evaluate the limit as x approaches -1 for this transcendental function. So the first question we asked before was, can we plug in -2? So what are we going to ask ourselves? Can we plug in -1? Let's see what happens. If we plug in -1 on the bottom, what happens here? So if you have e 3x plus 3 minus 1, then we have what? E 3 times -1 plus 3 minus 1. This is e to the -3 plus 3 minus 1, which is e to the 0 minus 1. And what is e to the 0? Remember, any x to the 0 is equal to 1, where x does not equal 0, right? So anything to the 0 power is just 1, okay? Except 0. You can't say 0 to the 0. But here, so now you have 1 minus 1, and that equals 0. So, I don't know if so here, notice that we get 0 in the denominator when we plug in -1. So you're not allowed to use -1. So now, because we have 0 in the denominator, let's see what happens for the numerator. Okay, what happens if we plug in, let's have this here. What about the numerator? So for the numerator, if we have 2 times ln of -x, and we're going to say x is -1, what is 2 times ln of -1? this becomes 2 times ln 1. But what is ln 1 for what we did before? Remember, ln of 1 is 0. So here we just have 2 times 0, and that's 0. So notice that the numerator, we got 0 over 0. So this is no good. But now, what does L'Hopital's rule say? L'Hopital's rule states that if we get 0 over 0 or infinity over infinity, what we're allowed to do is we're allowed to take the derivative of the top and the bottom of the function. So from here, we're allowed to say that the limit as x approaches minus 1 of 2 times ln negative x over e to the 3x plus 3 minus 1, we are allowed to take the derivative of the top and the bottom. Now, taking the derivative for the top and the bottom is not, it takes a little bit of work. So what I want you to do is pause the video, take your time, try and figure out what is the derivative of the top. Okay? Here, what is the derivative of 2 times ln of negative x? Well, remember that what is the derivative of ln of x? Oh, sorry. What is the derivative of ln of x? That's equal to 1 over x times the derivative of x, or the derivative of what's in the inside. So then here, we're going to have 2 times 1 over negative x times the derivative of negative x. Okay, and what's the derivative of negative x? That's just negative 1. So this is times a negative 1. Okay, so then this just becomes negative 2 over negative x, which is just really 2 over x. Okay, so that is the derivative. 2 times ln of negative x, the derivative is 2 over x. Okay, so then now the derivative of the top is just 2 over x. Now what about the derivative of the bottom? Let's see. This, let's take out a scrap paper or something, right? So what is the derivative of e to the 3x plus 3? Oh, this one's not bad, right? What's the derivative of this? Well, okay, what's the derivative of e to the 3x plus 3? Well, it's just e to the 3x plus 3 times the derivative of the top. And what is the derivative of the top? This is e to the 3x plus 3 times, what's the derivative of this? It's just 3. And what's the derivative of minus 1? This is 0, right? So then you just have is equal to 3 times e to the 3x plus 3. Okay? So this represents the derivative of this. So then we'll just put that here, 3 times e to the 3x plus 3. Now, we have this over here. Now, can we plug in negative 1? Question mark. Can we do it? Let's see. Let's look at the bottom. You have 3 times, let's see. This is equal to the limit as x approaches, a limit as x approaches minus 1. Well, what's on the top? You have 2 over minus 1. So this is what it is. But what about here? 3 times e to the minus, let's see. So this is 3 times minus 1 plus 3. So then notice you're going to get like the same. Oh, this one's actually not bad. So here we get 2, we get negative 2 is on top because 2 divided by negative 1 is negative 2. Then this becomes what? 3 times e to the negative 3 plus 3, but then that's equal to negative 2, 3 times e to the 0. But what is e to the 0? This is 1. So now we just have negative 2 over 3 times 1, and that's equal to negative 2 over 3. And that's it. Okay? So the limit, as this function goes to negative 1, it goes to negative 2 over 3. If you want, for fun, go to Desmos and plug this entire function in. If you plug this function in, you're going to notice that the function has to go to negative 2 over 3 at x equals minus 1. There should be some point over here, and whether it's open or closed, but the limit has to go to that point. Try and put it into Desmos to see what this graph looks like. I have no idea what it looks like, but okay. Let's see the next part. Aquí estamos. Okay. Let's see. Okay, for this one, let's try L'Hopital's rule for this one. This one's really not too bad. Here, can you take, now let's see. Can we plug in infinity? Notice if you plug in infinity, you get infinity over infinity. So what can we do here? We can use L'Hopital's rule. So we know that the limit as x approaches infinity for 3x cubed plus 5x squared minus 3x minus 2 over 4x cubed minus 6, this is equal to the limit as x approaches infinity. And here we could take the derivative of the top and bottom, because when you plug in infinity, you get infinity over infinity. So we could use L'Hopital's rule. So what's the derivative of the top? It is 9x squared plus 10x minus 3 over 12x squared. But notice, if I plug in infinity, you still get infinity over infinity. So we can go again. Let's do it again. So here now you could say that this is equal to the limit as x approaches infinity of, take the derivative again. So this is 18x plus 10 over 24x. But you see, if I plug in infinity, you still get infinity over infinity. Because here, it's like, what is 18 times infinity plus 10 over 24 times infinity? This is just, it's just infinity over infinity, okay? I'm not going to say it equals infinity over infinity. That's not good. But it just is infinity over infinity. So take the derivative again. So limit as x approaches infinity of 18 over 24. And as x goes to infinity, your answer is 18 over 24. Or how can you simplify this as a fraction? This is equal to 3 over 4, and then we're done. Okay? So L'Hopital's rule is very nice. Anytime we have like 0 over 0 or infinity over infinity, we're allowed to keep using L'Hopital's rule. Okay? Let's look at this one. Here, okay, notice for this one, can you plug in infinity? Probably not, right? Because this becomes infinity, so you can't. You get some infinity over infinity. So now what I want you to do is take the derivative of the top and the bottom. Okay, so limit as x approaches infinity. This function over this limit problem is equal to here. So this is equal to 8x minus 3 over, okay, what is the derivative of e to the 2x? So pause the video and try and do it. But this should be 2 times e to the 2x, if you're to take the derivative of this. What's the derivative of ln of x? This is plus 1 over x, right? And like, which derivative rule are you using? It's just the sum, right? You're not like multiplying or anything. Okay, so here, can you plug in infinity? You can't. You can't plug in infinity. So you have to take the derivative again. Because if you plug in infinity, you're going to get infinity over infinity. So now this is equal to the limit as x approaches infinity. Well, what's the derivative of the top? It's just 8. And the derivative of the bottom, what is the derivative of the bottom? This will be, let's see, e to the 2x. So this will be 4 times e to the 2x. That's the derivative of this. What's the derivative of 1 over x? Let's see. Well, let's see. 1 over x is equal to x to the negative 1. So what is the derivative of x to the negative 1? That's negative x to the negative 2. Because you're doing this, then a minus 1, right? So then this is negative 1 over x squared. So then here we have negative 1 over x squared. Okay? Now here, once you plug in infinity, let's see what happens to this. And I'm going to show it over here. Oh, sorry. I'm going to show it over here. Let me rewrite it. My bad. So you have the limit as x approaches infinity of 8 over 4e to the 2x, my bad, minus 1 over x squared. So notice, let's see what happens when you plug in infinity. This becomes 8 over e to the infinity, because e to the 2 times infinity is really just e to the infinity. But what is e to the infinity? This is infinity. And if you're asking why is this equal to this, because what does the graph e to the x look like? The graph of this looks like this. And notice, you see, as x is going to infinity, f of x is going to infinity. So e to the infinity is just going to infinity. So this is really just infinity down here. And what does this equal? What is 1 over infinity squared for this 1 over x squared, right? Like if I were to put in infinity in here, this is just 1 over infinity, but that's really 0. So this is really 0 over here. And this is just 8 over infinity. But what is 8 over infinity? This is just really 0. So we did all that work to say that this limit goes to 0. Okay? Oh wow, we got 17 minutes. That's a long video. It's a long lecture. I really wanted to do this, but I don't have time. I gotta go teach my college class. What I'll do is I'll give the delta math, and if you see a question like this, or if you see a question like this, I want you to see how they do it, and we'll show it in class, or I'll show it in class tomorrow. Okay? Have fun. I'm proud of you.